as you already know, this Z test is the test whenever the sample size is either equal to or greater than 30, right? So this is a large sample test. So for this test, first of all, let us see the critical values for some of the most used this level of significance, right? So just write down this table, level of significance, which we represent by alpha, right? And so we are doing it for various values. So 10%, 5%, and then 1%, then 0.05%, and this is 0.2%, right? In percentage, it is 10%, 5%, 1%, 0.5%, yes, and 0.2%. So for this much level of accuracy, let's write down the values for one-tailed test and two-tailed test. So for one-tailed test, these values would be available to you in any statistical table, right? And just for the time being, just note it down. So for one-tailed test, we have the critical Z values as minus 1.28 or 1.28. We have minus 1.645 or 1.645. Now this depends on the, whether your test is a left tail test or right tail test. For left tail test, you will take this negative values. For right tail test, you will take these positive values. Then we have minus 2.33 or you have 2.33. Then you have the value minus 2.58 or 2.58, and then you have the value as minus 2.88 or 2.88. Then for the two-tailed test, your critical Z values are they are minus 1.645 and 1.645. So in this case, we are taking the both sides of the distribution, right? So minus 1.96 and 1.96. So then we have minus 2.58 and 2.58, and then we have minus 2.81 and 2.81, and then finally you have minus 3.08 and 3.08, right? So these are your values, critical values. So let's see a question problem based on this statistics. So first of all, you should know what is the test statistics whenever we are talking about this Z test, right? So first of all, let me write down the test statistics for you. If suppose you wanted to compare the means for two different you wanted to compare the mean of a sample and a population. So suppose this is your population whose mean is mu, and from this population you have a small sample whose mean is say x bar. So in that case, your test statistics Z is given by x bar minus mu divided by sigma divided by square root n. Now what are all these? Now this capital X represents a random variable. Now this is not just the value of sample mean, but this is the random variable representing sample mean. So that means it could vary according to the sample space. What is mu? Mu is the mean of the population as usual. What is sigma? Sigma is the standard deviation of the population. And what is small n? That is the number of elements present in the sample. Right. So this is the test statistics. Now let's see, move on to the next, the problem, and you'll understand the topic well. So let me write down the statement first. The mean lifetime of a sample. So here the question is the mean lifetime of a sample. So the question here says that the mean lifetime of a sample of 100 fluorescent light bulbs produced by the company is computed to be 1570. So you are to determine what is the population, what are the parameters for population, what is the sample, what are the parameters for sample. Now they are saying if mu is the mean lifetime of all the bulbs which are produced by the company, you have to test the hypothesis that mu is equal to 1600 hours against the alternative hypothesis. So this is your null hypothesis, this one. So this is your null hypothesis. This is given to you. And the alternative hypothesis that mu is not equal to 1600 is given to you. And moreover, in the question they have given you the level of significance. So let's proceed firstly for the level of significance 0.5. So that means we are to check for 5% level of significance. So that means we are saying 95% of the time our decisions are correct and only 5% of the times they could be incorrect. So in this question they have already given you the null hypothesis. So your null hypothesis here is H0, which is mu is equal to 1600 hours. So you have to check the mean here. And the alternative hypothesis that is given to be mu is not equal to 1600 hours. Right? Okay, so after writing this level of significance, we have to write our hypothesis, which is the null hypothesis and the alternative hypothesis. So after that, what we do, we identify the parameters here given in the question. So what is this parameter? 100. So you are given a sample of 100 light bulbs. So that means your elements which are present in the sample n, small n, that is given to be 100. And then what you are given? You are given that the mean of this sample is 1570 hours. So that means this is the mean of the sample. So this is x bar, which is 1570 hours. And moreover, they have given you a standard deviation of 120 hours. So the standard deviation here is given to be 120 hours. So for this standard deviation, next you are to check that for mu is equal to 1600. So this is the mean for the given population. So your mu is given to be 1600. So according to this, we will calculate the test statistic. So for what is the test statistics for Z test? It is this x bar minus mu divided by sigma by square root n. So let us substitute the values here. So we have the value of x bar, which is a random variable corresponding to sample mean. So this is the value 1570 minus the mean of the population which we wanted to test. So this is 1600 divided by sigma, which is the standard deviation. So it is 120 divided by the number of elements present in the sample. So that is 100. So according to that, so basically this is S only, the standard deviation for sample itself. Yes. So according to that, when you compute this, so you will have the value minus 30 divided by 12. So that would be minus 2.5. Okay. So minus 2.5. So what is this? This is your calculated Z value. So now once you have your calculated z value, the next thing is to get the tabulated value. How do you get the calculated value? You'll go and look for the critical values. So for the critical value here, we only require the level of significance, which is 5% level of significance given. So we'll go and look at the table for this z distribution. So now if you notice here that your test is this one, your hypothesis is these two. So that means this would result in the two-tail test, right? So corresponding to this two-tail test, let us see what is the value for z variable. The value, if you look at this table of level of significance for z values, the value at 5% level of significance for two-tail test. Now because your hypothesis is stated in this way such that your test would be two-tail test. So accordingly, for 5% level of significance, this is your range of values. So minus 1.96 to 1.16. So let me draw the critical region. So your tabulated values, they range from minus 1.96 to plus 1.96. So your distribution would now look something like this, having the critical ranges. So this would be the region. So this value would be 1.96, this would be minus 1.96. So this would be your critical region. If this is your critical region, right, these two are your critical region. So now you have to check for the calculated value here. So if you see, your calculated value is minus 2.5. So you have to see where this minus 2.5 would lie. So from here, because this is the number line, this value would infinity, this value would be minus infinity here on the left hand side. So your value would lie somewhere here, minus 2.5. So obviously this value lie in the region of rejection. Yes. So therefore, so let me write down, because the calculated value is less than that of tabulated value, therefore in this case you reject the null hypothesis. Or in other words, you may also say that your calculated value, the calculated value lie in the region of rejection. So therefore we reject our null hypothesis. If you reject your null hypothesis, therefore we accept the alternative hypothesis. If you accept the alternative hypothesis, that means the statement H1, which says that mu1 is not equal to 1600 hours, is true. So that means this is your conclusion here, right? So based on this, you may conclude that our alternative hypothesis is correct and the mean of all the light bulbs which is produced by the company is not equal to 1600 hours. In a similar manner, for the second case, we may test it for 1% level of significance. So for 1% level of significance, you go back and check the tabulated value once more. And moreover, this we have a two-tail test. For two-tail test, what is this tabulated value here in the table for z test? So for z test, the tabulated value for 1% level of significance is this one, minus 2.58 to 2.58. So our value is minus 2.58 to plus 2.58. So accordingly, your distribution would become, if this is your distribution, right? So this value would be plus 2.58 and this value here would be minus 2.58. So accordingly, this would be your critical region and the region of rejection, and this is your region of acceptance. So now you check the calculated value here. So let me write down first the calculated value. So what value did you calculate using the test statistics of Z test? So our value was this, minus 2.5. So it is minus 2.5. So where does this minus 2.5 lie? It would lie somewhere here, because this calculated value is greater than that of the tabulated value, which is minus 2.58. So therefore, you may say that your calculated value lie in the region of acceptance. If it lie in the region of acceptance, that means what you are going to do, you will accept your null hypothesis. So in this case, if you wanted your decision to be 99% correct and only 1% wrong, so in this particular case we say that the null hypothesis is correct. So that means H naught, which was given by mu, is equal to 1600 hours is correct. So therefore we say that the mean lifetime of all the bulbs which is produced by the company is equal to 1600 hours when we take the level of significance to be 1%. So I hope you understood this concept well. Well, that is it for this video. Thank you for watching.